Welcome to the next subtopic in our 1.1 linear relationship internal, how we're actually going to graph our data when we get it. Okay, so the relationship we want is a linear relationship where y is proportional to x. So that funny looking symbol between y and x means proportional. Okay, so in terms of the graph, we want basically a title for the graph describing the two variables, both axes labeled with the quantity and the unit, and usually the x variable at the bottom of the graph is the independent variable, but sometimes that's not always the case, like when one of the variables is time goes at the bottom. We also need an appropriate scale that is the same distance. That's what equidistance means between all of the values, and sufficiently large to cover all of the values of our range. Points are plotted as crosses, and anomalies, as you can see from the diagram there, are identified by a circle. And finally, we need a line of best fit to go through our values. So in terms of analyzing the graph, we also need a gradient, and that's calculated by the change in the y value divided by the change in the x value, which we looked at in our external with mechanics. And you have to use at least 2/3 of the line of best fit when you're doing your calculation. Okay, and the unit is calculated by basically the unit for y divided by the unit for x. So for example, if it's going to be force against, say, the extension of a spring, then the units will be force divided by distance, units being newtons and of force, and the units of the distance being in meters, so it's newton meters as the unit for the gradient. And the intercept, which is your c value, it's going to be the value that cuts the y-axis, when x equals 0, and the unit for intercept is going to be the units of the y-axis. Just the equation for a line in a linear relationship is y equals mx plus b, but remember that you have to make that equation fit the actual experiment that you've done. So y and x will be based around what your independent and dependent variables are and what you plotted for your graph for your experiment.